Bismillahirrahmanirrahim. This is the second video of the series on energy and power, and in this video we'll be solving end chapter problem 1.3 part D, E and F. In the previous video we had solved part A, B and C, which were for the continuous time signal, and now we'll be discussing the discrete time signals and solving these three problems. Just to recap, in the previous video we had given an idea that if the signal is simple exponential like this 3x or e raised to power x, simple exponential, then this signal will have finite energy, and we take help of this formula that energy is power into time, or power is energy divided by time. So if we have finite energy, then we can calculate power. Finite energy divided by infinite time will be 0. So the average power in this case will be 0. So you have to keep this in mind while solving the problems. And then this type of signal is also called energy signal, where the total energy is less than infinity. And the next type signal could be the sinusoidal signal or complex exponential signal. And so you can see that this signal is continuing, and so this can straight away say that this will have infinite energy. And when the energy is infinite, then the power will be, we can say it's constant, like this is infinite energy divided by infinite time. So we'll have a constant value of power. Okay, so with this in mind, now this was also for the continuous time, but this is also applicable for discrete time signals. So let's now straight away go to the problems. Okay, this is power signal. So the first problem is that we have x1n half power n un. Now this is a simple exponential signal, and we'll be using these two formulas for calculating the energy and calculating the power. So our signal is x1n, so for xn we'll write x1n square, putting in the value. So this square comes in, it will become 1 by 4 n un. And now we have to keep in mind that un really means that the signal or the un has a value 0 for less than 0, and it has a value 1 for greater than 1. So for less than 0, this the output will become 0, and therefore our limit will now change from n0 to infinity, because only in this range the signal will be present. And now we take help of infinite geometric series. So this is the formula. We can write it as a divided by 1 minus r. Now a in our case is 1, so we'll write 1 here. This is our r, so we can now write 1 divided by 1 minus r, that is 1 over 4, and simplifying we get the answer 4 over 3 joules. So this is a finite energy, and as we had discussed, we should have 0 power. So by using this formula, infinite energy is 4.3, time is infinity, so anything divided by infinity will give 0 power. So this is the answer for the part D, and this is the same that we had mentioned, that we'll have finite energy and 0 power for simple exponential signal. Okay, the next signal is a complex exponential signal. You can see there is a J here. That means this signal is a complex exponential signal. And if you see example 1.3b in the previous video, your concept will be more clear. But anyway, we'll proceed with this. So this is can be written in this form r e raised to the power j theta, where r is the magnitude. So our case the magnitude is 1, and this will represent the phase angle. Okay, so x to n magnitude of this thing is equal to 1. And so now putting in the energy formula, this will be 1, and 1 summation from minus infinity to plus infinity. That means 1 plus 1 plus 1 plus 1 up to infinity will give us the result infinity. Now coming on to the power formula, we just again put in the value here 1, and now here the limit is minus n to plus n, and so this sum will be equal to 2n plus 1. And how will that be? Let's see from this example. Let's say n is equal to 2. So from minus 2 to plus 2, minus 2 to plus 2, we'll have 5 signals. You can see the 5 signals will only come if we have 2n plus 1. That is 2 into 2, 4 plus 1, 5. So this will make 2n plus 1. So we write 2n plus 1 for this. And now 2n plus 1 and 2n plus 1 will get cancelled. So power will be 1 watt. So energy is infinite, but power is finite, 1 watt. And this conforms to what we have learned, that the complex exponential signals will have constant power and infinite energy. Now finally the last question, where x3 is cos pi by 4. So we just plug in the value cos pi by 4, mod of cos pi by 4, and then square we bring it inside. So cos square pi by 4. Now we'll use the formula that we know, this formula, cos square formula, to break it down. So we have broken it down in this fashion, and now 2 and 4 cancel, so it will become pi by 2. And now we can separate the two terms, separate this and this. And as we have discussed in continuous time, that integration of a sinusoidal signal is equal to 0 over whatever time period we consider. Similarly, for discrete time, the summation of a sinusoidal signal over an infinite time period will also be equal to 0. So putting in 0 here for the sinusoidal part, and in this case now we take half outside, so it is summation of 1 from infinity, minus infinity to plus infinity. And again this same concept, if you keep on adding 1 plus 1 plus 1, so it will go up to infinity. So we can say that our final answer will be equal to infinity. This will become infinity, this is 0. The final answer is energy equal to infinite joules. And same way the powers formula, plugging in the values of this, separating the two, and here also will say that the summation of cosine terms will be equal to 0, putting in 0 this. And now we have discussed earlier also that the summation of 1 from n minus to n plus will be 2n plus 1. So we write 2n plus 1 here, and these two gets cancelled, so our final answer is half watt. So I hope this gives you an understanding how you can solve this type of equation. Thank you.